Today we're gonna be learning a very important topic from chemistry. It's gonna be like the hybridization. In fact, today I will be not explaining the basic of the hybridization. Okay. However, today I'm going to explain you the short trick. Okay, how you can actually find out the hybridization in a fraction of time. I will explain you today the structure way and the mind trick I developed. That trick will be really helpful for your examinations. Okay, hybridization. So hybridization, this hybridization topic, I'm not going to go for a basic of hybridization, how it has to be made. But today just I will give you the short trick. Alright, so two method is very important, and two method even we can find out the hybridization. The first method is called structure method. Okay, structure method, and secondly that method has been developed by me, that is called by counting valence electron method. Valence electron method. Okay, so structure method and valence electron method we are going to discuss today. Okay, so hybridization basically when we intermix the atomic orbital together and form a new orbital, right? Alright, so structure method and valence electron method, how we have to find the hybridization, let's understand. Okay, so before I get started with the structure method, let me tell you what are the things you have to keep in your mind in order to find out the hybridization. Alright, so the first thing is this need to be memorized. Okay, there are actually different type of orbitals, like in terms of S, P, D, F. Alright, so S orbital, P orbital, D orbital, and F orbital. So hybridization is basically the intermix of orbital to get new orbitals. So what you need to remember is, if the total number of electrons, sigma bonds are, is 2, S and P, only these two. If total number of sigma bonds are 3, for example, then the hybridization will be SP. Okay, because in S orbital maximum 1 orbital, P there are 3 orbitals are there, D there are 5 orbitals, F there are 7 orbitals. Yes or no? So if are 6. Okay, so this you need to remember. If the sigma bonds are 2, then the hybridization will be SP. If 3, SP2 and SP3. If it is 4, 5 and then 6. Alright, so you need to remember this. Now let me tell you the structure method. Alright, so structure method, for example, let's say, what is the hybridization of beryllium chloride, for example? Beryllium chloride. So beryllium chloride central atom is beryllium metal. Here one chlorine is there, here another chlorine. That means here one sigma, here one sigma bond. Yes or no? There are how many sigma bond? 2 sigma bond. Sigma bond is formed in between two atoms if it is a single bond. Okay, if an atom is connected with a single bond, then we call it sigma bond. So here only single bond, here also single bond, that therefore it will be 2 sigma bond. 2 sigma bonds, that means here hybridization will be sp. Okay, so beryllium chloride hybridization is sp. This is the structure method. Alright, so now I will tell you how you can find even valence electron method. The same concept, beryllium chloride. Alright, so beryllium chloride valence electron you have to find out first and add it total, and then you have to write it. It's very interesting, it's very nice. You just remember, just have a look at this video, it will be clear for you. Alright, well, so valence electrons of beryllium and chlorine to be added. Okay, total number of valence electrons to be added. If the total number of valence electron is 8 or less than 8, then you need to divide by 2. Always remember, if total number of valence electron is 8 or less than 8, 8 or less than 8, then you have to divide by 2. After dividing, the quotient will be the sigma bonds. Okay, so after division we'll get questions, so that quotient will be the sigma electron. If the total number of valence electron is more than 8, okay, I write here, electron is more than 8, then you must divide by 8. Alright, to trick. If total number of valence electron if 8 or less than 8, you just need to divide by 2. The quotient will be the sigma bonds. If the total number of valence electron is above 8 or more than 8, then you just need to divide by 8. The quotient will be the sigma bond. This is the rules for the second type of hybridization. Okay, so valence electron method is. Okay, so shall we get started with some other example? Maybe first let me tell you with the beryllium chloride. Okay, now beryllium chloride, for example, valence electron method. Okay, so first and foremost, what you have to find it? Need to find the valence electron for beryllium and chloride and just need to add. That's all. Alright, so here we go. Beryllium atomic number we know 4, its electron structure is 2,2. That means 2 is the valence electron here. Yes or no? And for chlorine atomic number 17. Yes or no? And its electron structure 2,8,7. So what is the valence electron of chlorine? Valence electron means the last shell electron. Okay, we have 3 shells K, L, M. So the last shell, how many electrons are there? That electrons need to add it over there. Okay, so here valence electron for beryllium, this is the valence electron for chlorine. So this number need to be added. So 2 plus 7, but here chlorine 2 times. That is why it need to be multiplied by 2. So 2 plus 7, 2 times is 14. 2 plus 14. So it will be equal to 16. I told you, if total number of valence electron, if you are getting 16, then you need to be divided by 8. So therefore, I will divide here by 8. After division, what will be the questions? 8 2 times, that means you are getting after division 2. So if the total number of sigma bonds, if you are getting 2, that means the hybridization will be sp. Alright, so I told you here, if there are total number of sigma electrons is 2, then it will be sp. Are you getting me? Understand? So in this way you can find it. Alright, so shall we do other example maybe here? This you need to remember, memorize this. Memorize. So 2 total number of sigma bond is 2, therefore sp hybridization. If it is 3, then sp2. If it is 4, sp3. Now other example let us see. For example, let's say water. What is the hybridization of water? Well, the hybridization need to be found out in 2 ways, structure method and valence electron method. Okay, so let me do first valence electron method and then I will just move towards the structure method. That will be even easy for you. Alright, so valence electron method is a very good method. Just need to be counted the valence electrons of given compounds. Alright, so hydrogen, here we have 2 elements, hydrogen and oxygen. Atomic number of hydrogen is 1, that means it has 1 electron in the last shell, so valence electron is 1. Oxygen is 8, it has 2,6 electronic configuration. Well, so here 6 will be the valence electron. So what I said, you have to find or you have to sum the total number of valence electrons. So here 1 and here 6 to be added. But make sure that here how many hydrogens are there you have to see. The hydrogen number is 2. That means 1 2 times plus here 1 oxygen. Okay, 1 times of valence electron is 6. So 2 plus 8 is equal to 2 plus 6 is equal to 8. So now you got the total number of valence electron is 8. So I told you if total number of valence electron is 8, then you need to divide by 2. Therefore I can divide here by 2. After dividing, you are going to get 4. So this 4 is known as sigma bond. How many sigma bond? 4 sigma bond. I told you if there are 4 sigma bond, then the hybridization will be S and P will be 3. Can we write sp4? sp4 cannot be written because p subshell has only 3 orbital. So maximum it can be 3 only. It can be 1 or 2 or 3. P I am talking about. So sp3 will be the hybridization for water. If you use structure method for hybridization, so you will get the same sp3. But structure method, what we do here, water, the central atom here, oxygen. Yes or no? So oxygen atomic number is actually 8, so it has 6 in the outer shell. Therefore, here we have 6 electron. Out of 6 electron, only 2 electron is taken part in the bond formation. That means 2 hydrogens are there. So 2 electron will be utilized by 2 hydrogen. Here 1 hydrogen, so they will make a bond. Alright. Now there are 2 lone pair. Understand? This 1, 2, 3, 4 electron did not take part in the chemical bond formation. Therefore, here we have 1 sigma bond, 1 single bond here, that means sigma bond. So this lone pair also will act like a sigma bond only. Okay, so this is also another sigma bond, this is also another sigma bond. So 1, 2, 3, 4. Total number of sigma bond is how many? 4. So 4 means it will be sp3. 4 it will be sp3. Are you getting me? So in this way you can find the hybridization in an easy way. This is the easy way to find the hybridization in 2 ways. In fact, the structure method and the valence electron method. Okay, so which method is really helpful? You just follow up. Both of them are quite good. Both of them are actually very nice, so you can follow up any of them. Well, okay, so this is about hybridization. Another thing, let me tell you, some other organic compounds are also present. So this trick, this valence electron method can be used only for the neutral compound. Okay, valence electron method can be used for neutral compound, not charged compound. Okay, if there are ions in the compound, then this this method may be work out, may not be work out.